It's great to be with you. Last year was my first Clojure Conj, so it's pretty neat to be up here a year later talking about what I'm building with Clojure and Datomic and Clojure scripts and all the other tools that we have. So I'm really grateful for all the people involved in producing these tools, since they're helping me make progress on things that I've been working on for a long time and kind of finally getting somewhere. So the title of my talk is Computable Stories, because that's what Session is about. It's about stories that are about computations, stories that are computations. So let me start unpacking that for you. So here's a quote, sort of our starting point. Most of our systems live outside the bounds of any single process that we write. So this is a quote from Rich Hickey from the first database as a value talk. And it's a point that he elaborated upon yesterday in the keynote. And the point that he was making was sort of no matter how nice it is inside the bubble, inside of our individual process where we have the facilities of Clojure and the state identity kind of management situation we have there, these processes live in a broader system. And that broader system can potentially reach into our process. And the complexity from the broader system can reach into our process and make things complex for us there, even with those facilities that we have. So kind of the canonical example there is the database. Complexity in the database reaches into our individual process and makes it harder for us there. And it's not only just kind of what happens within that bubble, but it's about the boundaries of the bubble, right? So what does it mean to be an application server? Part of the definition of that is sort of defined by the attributes of this greater system. The attributes of the database define what it means to be an application server. The database is over there. That limits the architectural options you have. It sets the boundaries on the bubbles in which we work. So the database is not the only thing of this nature that's kind of reached into our programs, making life hard there, and then defining kind of the boxes in which our programs can operate. Another thing is the humans. Humans are part of the systems as well, right? We are in there setting up servers, standing up systems, changing the architecture of our systems, creating values, inserting them in places. We're as much of a part of these systems as the database, as the application server, as anything else. So the problem is when we are computing as humans, sort of within the language of the system, there's no information model, there's no process model, there's no notion of update, there's no kind of built-in notion of conveyance. We're sort of flying blind without the sort of facilities of Clojure inside the process and outside the facilities of kind of however we set up our system to handle some particular case. And what ends up happening is we're just constantly blowing our foots right off. Who's ever overwritten a piece of data from the REPL, right? This is stuff that happens all the time. We set up some system. We initialize it with some parameters. We close the REPL, and then a week later we forgot what we did. Maybe we remember in generalities what we did, but what was that second argument for that function that we used to initialize this thing? And maybe it's usually this, but in this special case it was this other thing, and now we forgot what that was. We come back to our system, and now we kind of have to remember that from scratch. Oh, we get this error, we Google it again. Oh, this is something that we remember was the situation in this particular case. So let's fix that. So we have these kind of stories of successes and triumphs and stories of failures. And we can't share that knowledge. There's no sort of representation where you can say, this is how I stood up my Hadoop cluster and ran these things that you can just kind of pick up and give to someone else. It's always a totally ad hoc process of, let me write some tutorial online in some particular format in a particular place. And remember all the steps. Hopefully we can remember we put all those things in there. It's a pretty heavyweight thing to try to share to try to share our stories that we're living every day. And the ultimate cause of this is, this is a disaster of unmanaged state at the level of human computation when we're computing with our systems. That's kind of the ultimate cause. And the tendrils of this, there's bazillions of them. And maybe at the end of the talk, I'll have time to unload the full clip, at the REPL and kind of enumerate all the ways that this is causing problems. But, we can kind of see that already, just kind of at a basic level. We can't remember what we did. We can't reproduce what we did. We can't share it with other people. So kind of the question that I have is, what is the Clojure way for human computation? How do we apply the principles and methods and tools of Clojure and Datomic to this case when we're doing the computation? And kind of the key idea is, the thing that we can hook onto is narrative, because narrative is where humans meet computation. That's sort of the nearest concept that humans can relate to what computation is. So here's a basic observation. Computation is a narrative, and narrative represents a computation. They're both kind of essentially about going from point A to point B through a series of steps, sort of a series, an evolutionary process that does this transformation from point A to point B. And it's all about that sequence, really. And that's kind of what defines both of those things. If you just take the last element of the sequence, then you've lost something essential, right? If you take the last part of the computation, the output, that's just a piece of data. That's no longer a computation. That's just a piece of data. If you take the last element of a narrative, and then they lived happily ever after, right? Like you've lost something kind of important, It's not just about the end, it's about what happened. And sort of the meaning of what, the end is in the context of what happened. The meaning of what's in the middle of the story is informed by what happens later and what happens before it. And the reason why we care about the overlap between these two concepts is because narrative is the most powerful way of communicating knowledge. It's the most general way of communicating knowledge. And for certain kinds of knowledges, it is the only way of communicating knowledge. And I don't think it's sort of an accident of evolution or something that humans operate on narratives. Narrative in, narrative out. We have sort of the little drama of our lives, and we perceive the state of the drama. We compute the next step, do the next action. The world responds, and the narrative continues. So session is a system for narrating computations, the sequence of inputs and outputs, right? This piece of code comes in, this result comes out. This piece of code comes in, this result comes out. The sequence of those pairs. That's the computation that we're interested in. And what we want to do is turn it into a value, because then we get all the benefits that values give us. Easy to perceive, right? Easy to perceive the narrative. It doesn't have to just be a bunch of text in the terminal. We can put it on a web page, web app, have pictures in it, and so forth. Easy to remember. We can actually remember what we did. Easy to fabricate, easy to reproduce, to relive that sequence of steps. There are some fields where that is kind of the defining critical issue of their time right now. Scientific computing. People doing experiments. How do you reproduce those experiments? They have no way to represent some structure that they can convey to do that. So you can convey to other people. Another thing that's pretty important is you can index these stories. You can kind of aggregate them, index them, query them, and so forth. So let's kind of move towards solving problems here. So in kind of the more abstract case of what stories do for us, and then move towards some demos of session of how this kind of pans out in our world. So the first thing, maybe the most fundamental thing, stories explain, right? Stories explain how the world came to be the way that it is, how some artifact was created. That's sort of, oftentimes, that's the best way to understand the thing. Sometimes it's the only way to understand the thing is sort of how it was created, how it came to be. So, who's ever been surprised by the output of their program, right? Like, this is, this happens to us like every single day. And what do? Kind of the canonical thing to do, you get some piece of data, you don't quite understand what it is or what it means, is you got to go back up the sequence. You got to go see the narrative and see the actual steps of how it was created. Whether it's the detail of, why is this date, does it have a time zone, and, what is it or whatever, like kind of the mechanical details of the computation, sussing that out, or understanding kind of what it means in a broader sense of it came from this data source, and this is what the computation was, and therefore, we computed this about this thing, kind of where it lives in the broader universe of things. Another thing stories do is stories instruct. It's pretty easy to see that if you have a story of how you went from A to B, and you want to go to B again, then you have a recipe of how to do that, right? Stories instruct you, how to do things. So, here's the story of how I installed Emacs, right? I downloaded this thing from this website. I installed something there. I cloned this Git repo and moved those files over here. I ran it, and I got this error. That's like the dramatic point in the story. And then, but then I overcame it because I did this, and now it works. So one person, one kind of hero went out into the unknown and came back with this experience that they share. And now other people can follow in that path. They don't have to kind of start over from scratch. There's a path for them to go on. So stories instruct. Stories also convey purpose, right? They don't just tell you why the world is the way it is. And they don't just kind of tell you how to change the world into some new state. They tell you why you would want to do that. They give you purpose. They convey a purpose. They convey sort of values of why you would want to do that. And this is really important because that's what makes stories human. That is what makes them something you can identify with as a human individual. And they do so in many different ways. Some of them are implicit. Just the fact that something happened, that the story exists, is sort of an implicit endorsement that this is something worth doing or not doing, potentially, depending on your interpretation. And some stories just go explicitly, I did this, and it was good because X, and you can see that. I implemented this algorithm, and things went faster compared to the old algorithm, and so forth. So stories convey purpose. So let's put some of these problems in context. So what's the biggest problem in Clojure? We actually know the answer to this, but feel free to shout out. Anyone? Anyone? So yeah, that's a problem. That's a problem. That's not the biggest problem, though. OK. All right, so the biggest problem is documentation. So I'm not just kind of using my own opinion here. We have this 2012 State of Clojure survey from Chaz Emmerich doing excellent work there. So 30% of the people, the highest number of all the possible options, said documentation, lack of documentation was the biggest thing holding them back. So obviously we have a bunch of experts here, so maybe it's not as big of a problem now. Parentheses may still be a bigger problem for the people in this room. So let me show you an example of how we might do documentation. So let's go to session here. And OK, so here's session. I hope people in the back can see this OK. Let's see. All right, great. So like I kind of mentioned earlier, the foundation of session is the idea of a series of input and output pairs. So let's sort of go ahead and make sort of a tiny little Clojure language tutorial. So we're going to say, here is apply a function. And here we have an example of an input and an output result. Let's say sort of apply a function across a vector, right? So we can say map plus 1%, and then put some data in here. All right. Looks like it actually works. Excellent. And we can sort of go on, right, and just kind of start adding these examples. Take two elements from beginning. Well, take two. So we're sort of building up this sequence of stuff. And right now, it doesn't look much different from your typical REPL session, other than, of course, we have a web app here. We actually have a simple version of par edit operating in here. There's this thing called subpar, which gives us some simple par edit capabilities, which is nice. But let's just do sort of one more thing, reverse vector. So we can fill this out here, reverse. All right. So I just kind of pretended to be the author here, sort of making examples of using functions that I've written or whatever someone else has written. And now we'll simulate being a consumer, a reader of these little stories. So you may have not seen what happened, but I just reloaded the page, right? Sort of the equivalent of closing the REPL window and opening it back up. And all the stuff I did is still there, or all the stuff someone else did is still there. And you can just kind of go in here and start reevaluating stuff. You're not kind of copying and pasting from some static text somewhere, and you're not sort of reevaluating code that's sitting in a text file that does not have the output, right? Like if you don't know what map does, and you see this example, and you don't have the output, when you evaluate that example, how do you know the output is correct? You don't. You have no idea if what you're getting is correct. Or if you see an error, is that the correct thing to be happening? And not only can we sort of relive the story that was written before, but it's sort of as if you have the storyteller right there, and you can ask questions about the narrative, right? Oh, here's the detailed part of the story, and I don't quite understand it, so let me sort of ask a more detailed question of what happens if it was like this, right? You kind of can ask the hypothetical questions in the midst of the narrative to enhance your understanding of it. So let me prepare the next demo and then go back to my slides here. All right, so play slideshow, all right. So that's sort of an example of an instructional session. Examples without the incidental complexity. You can just kind of go to it, start evaluating stuff, sort of minimizing other fuss. And it's certainly better for the author. All they need to do is deal with the Clojure evaluation environment. Maybe they're doing this for their own benefit. And it's certainly better for the reader/user. You have the examples right there in line. You could start evaluating stuff right there in line. You have the sequence of examples, and you can permute them, ask more questions about what happened. And it's certainly much easier to share and index. And sort of who's ever received an incomplete bug report, right? Like in this kind of system, there's a direct line from what I have now to, well, someone evaluated this example and it blew up. Check mark, send off to some repository indexing service somewhere, kind of notify the author of the library that you had a bad user experience in this case, and they can get the history of what you did, and the annotations that are happening behind the scenes in session, sort of adding meta information. And you can go beyond that, of course, submitting tests. Why are we not collectively creating repositories of tests? And it's because there's no way to kind of share those lumps of stuff in a reasonable way, but also because there's no user interface hooks. And this provides user interface hooks for those sorts of things. This thing is something we think should be a test. Click this, send it off to the central test repository or whatever. So let me give you another example, a sort of more complex example of what we can do. Hopefully things have loaded here properly. Yes, OK. So who read the Codec blog post? OK. So who was interested in kind of analyzing their own repository? Okay, so how many people went ahead and actually did that? A few, okay. Actually, a decent fraction of the people that raised their hands for the second question. But still, there's quite a bit of drop-off in that conversion funnel. And I would argue the reason for that is the same reason why, what happens to many projects, which is, you have this kind of static bit of code and maybe some explanation of how to use it, but you can't just kind of jump in and start evaluating stuff and start doing stuff. So right here, I have a session that goes ahead and does a bunch of analysis, or some analysis on the Clojure GitHub repo. So I'm going to go through and, so when these things load, they're essentially representations of what happened. And I want to reproduce or sort of relive what happened. So I'm going to go ahead and step through some of these computations. Oh. All right, well, that's a little suspicious. Let's see, well, let's see what happens here. So I'm going to step through these computations. Okay, all right, now I'm starting to have some confidence that this is actually doing something good, right? If I did not have the output together with the input, I wouldn't necessarily have confidence that my reevaluations were doing the correct thing. So I'm going to explain some of this code at a point when I kick off a more substantial computation. And okay, yeah, we're almost there. Okay, so this is a little bit more substantial computation. It'll take 2 minutes or so. And what it's doing is, so in the codec example in Rich's blog post, the kind of computation given as an example was finding the novelty that's being introduced into the repository. So, a given commit, it modifies various code, and during that process, you may be introducing new definitions for functions. Hopefully, that's what you're doing. And then the question is, when, given a function, given the symbol, what are the unique definitions associated with that have happened during the history, and when was the unique time that was first introduced? So, for instance, for the Clojure core map function, there's I guess 4 different definitions and those are the corresponding commit entities when those different definitions were introduced. And just to kind of show you a little bit more stuff here, we're still computing the commit, that thing there. But so one of these commit entities basically looks like this, right? You have kind of the commit message. In this particular case, some tests were introduced, things like the committed at time, the SHA, so on and so forth. So we're still waiting for this thing to finish, but while we're doing that, let me sort of show you what you can do when it does finish. Ah, well, there it is, great. So even without having had the computation in hand, I already had some code here that kind of shows you what the structure is, right? So we take the first from that commit sizes thing, and you can see the first thing is a big number, and the second thing is a smaller number. And if we just kind of look at the structure of the code, it's pretty obvious. The first thing is the commit entity, and the second number is the number. So it's the number of new codecs, novel codecs introduced in that commit. And I'm kind of interested in that because I want to see how many new codecs are introduced in each commit over the history of the Clojure repository. Because I think that's an interesting question, and it's launch-off point for sort of more questions. So we can take that data and just make a plot. This plot is a Clojure expression, Eden data. It's a tag literal. When it gets sucked into the browser, it kind of turns into a Java object or a JavaScript object. So commits can have the same committed at date. So we need to do a little bit of transformation to first accumulate all the commits that happen at a particular date, and then turn that into the plot. And that's what you get. You see there's a few commits that totally dominate. There's just like tons and tons of new things introduced in those commits. And you can find those pretty easily by filtering on the commit size variable there, get things bigger than 400 different codecs, touch those entities. And you see, okay, one of them is when they added the 1.0, introduced that thing in all the metadata. Another one is removing some deprecated reader macro from a bunch of functions. And then we can do things like, well, let's filter things that are all under, commits that are under 100 different things changed and kind of see that. So it kind of looks like the most intensive period of Clojure development was around here, 2010, June, June and July. It seems like a bunch of stuff was happening there. And if we're kind of interested in Clojure historical research, we might want to continue looking in that direction. But that's sort of not really the point of my talk. The point of the talk is this is a knowledge artifact, right? I've done this for Clojure. And now I've kind of solved that problem. And if I give this to you, it's pretty straightforward for you to just modify this code to operate on your own repository. Or you could also choose to continue the kind of Clojure branch and explore Clojure some more. But you don't have to start from scratch. You can just go in there, have a starting point, basis for modification, and you sort of know where the narrative goes. It's not just some API where, okay, you can theoretically do some capabilities, and it's also not an application. For me to turn this into an application, a parameterizable application, where you put in your repository and out comes a bunch of analysis, that's a bunch of work. And that's a bunch of work on top of the work I've already did. Let's go back to this guy here. So the advantages here is, I've basically done an experiment or produced some results. It's reproducible. And there's significant advantages over this model over an application, which would be kind of the alternative paradigm for sharing reproducible knowledge, right? You can't share reproducible knowledge from the REPL, really. The only paradigm that we have for doing that is for writing programs, writing applications, and that incurs a ton of complexity. So this is a simpler way of transmitting the ability to redo a computation without kind of incurring the complexity of going into the application space. So that should give you a sense of kind of what concession can do and why you would use it. So let's kind of go a little bit into the architecture. And this is the basic architecture. It's all about datomic in the middle here. And then you have these machines or conveyor belts that move things around between datomic and the person, and datomic and the system. The person and the system never interact directly. It's all going through datomic. And basically, we have, inside datomic, we have these sequences of actions and results, right? The human submitted this action, and the system produced this result. And those things are stored kind of in pairs in datomic. And the purpose of all this other machinery is to just kind of aggregate more of those things in the datomic database. So we have the UI that talks to the sentient being performing the universal computations. Put these guys in front of an iPad and you'll see. Anyway, so the UI is both kind of the web UI, and it's also, of course, the thing that talks to datomic, which right now we can't really do directly from the browser in the way that I want to do. So there's a little bit of a server-side component there, but it's quite thin. And what happens is, you submit your action. This thing makes a transaction into datomic. These services are listening to the datomic transaction stream and notice that the action, sort of the request embedded in the action, is talking about them. So they're listening to the transaction stream, notice a new action, do whatever it is they need to do, and then they report back to datomic. Now, and then that result gets sent over a WebSocket, and then back to the we're listening on a transaction stream here, and then sending over WebSocket back into the UI, and you're kind of seeing the result appear there, and then you can perceive the result, perceive the history, and take the next action. So there are several important points here. The first point is that we're not storing necessarily the data in session or in datomic. Session, datomic, in this case, it's all about storing stuff about the world. It's not about being the world. This thing might be, the data might be some terabyte thing that we're computing with. And we don't want to be responsible for storing it. There's services to do that for us. So we tell the services things. They may produce a value and kind of have it hang out within their own space and just tell us, I produced this, it was this big, and here's kind of the first few elements of it or whatever. The only thing you need back from the service is enough facts for the human to make a decision off of. So that does not necessarily include all the data. It could include a summary of the data. It could include metadata about the data and so forth. And that gives us a lot of flexibility. Basically, the idea here is we're just coordinating these services and telling them how to talk to each other. So for instance, one action will be, compute this thing, do this computation. The next action can be put the thing that you computed into this other storage service so that you can persist it, right? Take the thing that you have in memory in your process in sort of the Clojure evaluation environment and persist it to the storage service so that it can be around later. And when the person wants all those pieces of data about how many commits, how many codecs correspond to each commit, they just have it and they don't have to reevaluate all this stuff. We just persist that value. So the greater components of kind of this architecture is there's this process model, which is very important. There's the services, which I talked about. We need to achieve location independence for data. This is very important. And we need to be able to represent as many things as values as we can possibly can. We need to push the boundaries of what can be a value. If the database can be a value, then that's kind of shocking, right? The database as a value, that is pretty unbelievable. So if that's possible, then there should be a lot of other things that we should be able to treat as values that right now are just blobs of imperative building up of stuff. And if we can store those things as values, that gives us, that sort of enhances the power of session even more. So let's go through the process model. The basis, the starting point is the epical time model of datomic. We're building on datomic, so that's sort of not a surprise. And the only difference really is kind of what happens in those little boxes and sort of what those Fs can be. So this is kind of the process model right here. So inside of the database, we have these sequences of actions and results. And the process of adding stuff to the database is more of a two-step thing. So one step is the sentient being looks at the history of actions and results, right? That's the narrative. This is kind of the whole input, how you decide what you do. When you're looking, you're looking at the REPL session, you're looking in session, you see these inputs and outputs, you're cogitating, and then you decide, based on all of that data, what should be the next step. Oh, let me look at the first element of this list because I don't necessarily understand what it is. Or looks like everything works. Let me take the next step and build this graphics. You're kind of processing the entire history of the narrative to produce the next step of the narrative. And to do that, you produce an action. That's your job. That's the computation that you do as a human. You take that history and then you produce the next action. And then it's the process, it's the responsibility of the universe then to produce the result, right? And what it's going to do is it's going to operate on the action. Like the whole history of stuff, that's there, but that's kind of a vague thing requiring human intelligence to really make a predictable or to make a decision out of. And we want the things that we're telling what to do to make predictable decisions based on kind of local information. So the services, we'll just call that F, take the action and then resolve it into a result. And then between those two steps, we've sort of completed the entire loop of adding to our narrative. So human computation, narrative in, narrative out, mechanical computation, action in, result out, right? The whole thing, the thing of the work we do, that's the human computation. The mechanical computation is the individual steps. So services, not just Clojure evaluation, right? You know, if all we can do Clojure evaluation, then there's a hole in our model, because the reason why we're, you know, the thing that we're doing in the Clojure evaluation a lot of times is like talking to all this other stuff. So if that's, you know, sort of, if that's not incorporated in our model, then there's a huge hole in our model. And furthermore, there's no need to have a Clojure dependency in order to talk to these services. If you're talking to the Twitter API, asking it for some stuff, you know, why should Clojure be kind of a dependency in that path? You should be able to represent those things directly. You know, if you're talking to some huge computation service, some Hadoop thing, you should be able to talk to that directly and give it an instruction directly, get the result back directly without kind of going through some Clojure layer. And ultimately what we're doing is we're telling them to make stuff and report back. And we're also telling them to coordinate with each other. You know, sort of, okay, you guys set up whatever stream you need between you and, you know, do the dance and tell me, you know, what happened. I also believe that we can have services as a value. You know, APIs, the things that we have, they're not that great. And there's a way to do this in Clojure with values. So I don't know if I should get into it now, but you know, the problem is again, solving this location dependence problem. You know, if you need some queue to take things from point A to point B, and that queue is a place, and then you transfer your session to someone else and they want to run this computation, you know, they need that little component of the system as well, right? You know, if you have your session and you're talking to all these components of the system, you know, you need the components of the system to be values. Otherwise, when you transfer the session, you can't kind of transfer the computation along with it. And there's already a precedent for this, and Rich mentioned it yesterday, which is actors, right? You can move actors around from process to process. And it is possible, I believe, to take the part of actors that confines them to having a specific model of communication between each other and sort of break that off. So you have the ability to move these things around, but you're not stuck with only having one protocol that they speak to each other with. So 2013, we'll get that one. Another big problem, definitely very important to solve, location independence for the data. So it's critical for a sound information model. In your session, you can't be writing to specific locations kind of manually, because then you could overwrite them, or you know, it's just a huge mess. Critical for conveyance, again, you know, sort of passing the session to someone else. You can't be managing the location of data manually yourself. It should be an implementation detail managed by datums. So you know, you have some result, and you have some attribute on the result, the location. The location has various attributes like host protocol, whatever you need to kind of resolve that reference into a concrete thing. And if your code, you know, if all your code ever knows is, you know, I call first on the thing and it gives me the first element, like it's a seek, or the thing implements whatever protocols I expect it to implement, you know, then your code doesn't care, you know, that fact that, well, the data lives in 3 different places that Datomic knows about, you know, S3, my local storage, and my friend over here knows about this piece of data. And you know, when I tried to perform my operation on that data, a bunch of stuff happened behind the scenes to figure out which thing I should use and just kind of pipe it in to my program. So we can make it into implementation detail managed by datum. So we're not sort of saying like x1 equals this, x2 equals that, x3 equals that, you know, as we're evaluating our code. And then, you know, you get into some situation where you fix a bug in your, you know, transformation function, and then you reevaluate x2, but you don't reevaluate x3. And now, you know, x4 is not based on the right piece of data. You know, these are the things that we get ourselves into constantly when we're working with data at the REPL. And then, like I said, we need to lean on values as much as we possibly can. The benefits are just enormous. And we need to especially use them for things like graphics and UI so that we can perceive our data and perceive our session independent of the state of the systems that we're based on. If you have to launch some complicated system and then build up a bunch of state inside of that process just to see what it is that you did, like this is really bad. You have to be able to see, perceive the work that you did without having to launch all this stuff up. And the way to do that is to treat things as data. And the way to do that is to treat them as tag literals for things that have a little bit more juice than just kind of a map or whatever. So it looks like I have some time, so we can unload the full clip in 3 minutes. So the REPL. So what's the basic characteristic of the REPL? Oh, before I unload the full clip, let me just point out, the reason why I'm doing this is just point out how this is different from the things that we're doing and kind of enhance the understanding of the advantages of doing them the session way. Okay, so the characteristic of the REPL is this, right? It's just like Sisyphus rolling the boulder up the hill. You're just like rolling the state up the hill, rolling the state up the hill. You close the window, and then poof, it's a new day. You're back to, all the work is gone, and you're sort of committed, sort of condemned to a lifetime of, toiling your way, copying and pasting things into the REPL or reevaluating stuff. So there's no memory, and that's kind of the fundamental problem. So there's no memory of the state of the system before you did what you did, no memory of the state of the system after you did what you did, no memory of what the heck you even did, right? So there's no reproducibility. You can't reproduce if you can't remember. Limited perception, that's sort of a consequence of text-based thing. There's nothing to convey to something that can represent it in a better way. It's sort of DIY conveyance. You're at the REPL, and you want to save the fact that you actually did something in this universe, right? You want to persist it beyond your particular REPL session. And what we end up doing is just plop all over the place. Let me save this piece of data in this file. Let me put it in some other location in storage. And then you end up overwriting it, or someone else is overwriting it, or you can get confused about what matches up with what. It's a total disaster. And then you get transcription errors. Who's ever made a mistake copying some code from a tutorial, right? Like, we're sort of reduced to copy and paste as our mechanism of conveyance to and from the REPL. So there's no versioning. You have no idea what order things happened in. You had 5 versions of this function. Which version produced the file on disk? Who the hell knows? You come back to this a month later. Sort of no idea what happened. Likewise, no auditing. You have some piece of data. There's no way to get the history of how that piece of data was created. There's no context. In which context was this piece of data created? And of course, no extension of the environment of the REPL. Because it's such a low-level text-based thing, you can't kind of go in there and start adding send this example to the owner of the library so that they can choose to accept it into their database. 2 other systems worth talking about in my final minute here before I get forcibly carried off stage. So Smalltalk and Mathematica, both very innovative systems, especially in their time. So we're not doing Smalltalk images. The point is not to remember for the sake of the computer. The point is to remember for the sake of the human being. So we don't have to persist kind of all this state so that we have 100% reproducible stuff. We have stuff, we need to persist stuff so that the state of the human mind can come back to where it is. And Mathematica, we're not storing things in documents and notebooks. That's place-oriented programming. That's overwriting old information. And that's also not being able to dig out the information that you produced. If you're putting all your information to a document and someone else is interested in that information, there's some other component in the system that's like, give me all the new blog posts. You can't, it's very difficult to have automated systems to dig into these documents and extract out the information. You want your information to live in the level playing field with all the other components of the language of the system. So I believe this is a paradigm whose time has come, and with the tools that we have now, we can finally make it. So thank you.